Okay. Okay. So, today we're doing the method of substitution, and by the end of the period, or the end of this video lesson, you should be able to solve systems of two linear equations involving two variables using an algebraic method this time called substitution. So those are the steps to doing substitution. I'm not going to read them because they really won't really mean anything to you until we've done an example, but always go back and sort of refer back to those steps if you're having any difficulties. So the very first one is quite simple. It says solve the following linear system using the method of substitution. And we're always going to check our solutions as well. So substitution really means that you're going to take one side of one equation that has been isolated, and you're going to substitute it in for that variable that you've isolated into the second equation. And the reason that you can do this is because we are looking for a y and an x that are the same for both equations. And there's only one x and one y that satisfy that. Okay? That's that one point of intersection. And so we know, if I just put a little old square around this, this is already isolated for y, this first equation. In fact, both are. So I know that minus 2x minus 3 is equivalent to y. They're equal because it says so right here. So everywhere there's a y in the second equation, I can substitute the expression that I have here for y. Okay? So that's the very first step, is we're going to sub y equals minus 2x minus 3 into the second equation. So I'm going to put minus 2x minus 3 where the y is. And then I'm going to have equals. So I replace the y with this. Now I'm going to write the rest of the equation. And now you can see I have one equation with only one unknown. So I can isolate and solve for that one unknown. So when I move the 2x over to this side, and I move the 8 over, I'm going to get 5x equals 5, and then x equals 5 divided by 5, which is 1. So now what I want to do is I want to find my y value. So I'm going to substitute x equals 1 back into either of these equations. It doesn't matter, because for either equation we're going to get the same y value when x equals 1. So let's go ahead and do that. So now I'm going to say sub x equals 1 into 2. I chose 2 to sub into. So y equals 3x minus 8 is my equation, and I know that y then is going to be equal to 3 times 1 minus 8. Y equals 3 minus 8, and so y equals negative 5. So now I've solved for the y and the x, where they're both the same. So I'm going to say the solution might be, and let's order this point. We put the x first, and then the negative 5. So the solution might be 1, negative 5. We need to check. So we're going to check the point 1, negative 5, and we always check in the original equations. Well, we didn't really manipulate our equations because we didn't have to, because our variables were already isolated. But in subsequent examples, we will be isolating and changing equations. So always make sure that you go back to your original, whatever was given, and check. So this is going to be y equals minus 2x minus 3. So let's just check the first one. So this is going to be negative 5. So I'm taking the negative 5 from here and putting it in here, equals negative 2 times 1 minus 3. So negative 5 equals negative 2 minus 3. Negative 5 equals negative 5. Okay, so far so good. But just because it works for one doesn't mean it works for both. So we need to check the other equation. So y equals 3x minus 8. Again with minus 5 for the y and the 1 for the x. And we get minus 5 equals 3 minus 8. And 3 minus 8 is minus 5. And left side equals right side. It's just a coincidence that they both came down to minus 5. That doesn't always happen. As long as left side equals right side, we're good. So, last step, we're going to do a therefore statement. Therefore, the solution to the linear system is the point 1, negative 5. Okay? All right. Let's see if we can do another example. So, it says here, solve the following linear system using the method of substitution. So what I'm going to do here, because I don't have a variable isolated, I want to isolate one of the variables. So I either want to isolate 2x here and get it to be x equals, or I want to isolate this term so that it's y equals, or this one, or this one. It doesn't have to be in the first equation. So what I'm looking at here is, I'm going to pick the one that has a 1, if possible, if there is one, a 1 in front of the variable. Because I don't want to create fractions when I have to go and divide when I'm isolating, right? When in that last step, when we've got 2x isolated, then we have to divide everything through by 2, and I might be creating fractions over here. So I don't want to do that. So I'm going to pick the variable to isolate that has a coefficient of 1, if there is one. So I'm going to call this 3. So this is going to be x plus 2y equals negative 6. I'm just rewriting the original equation. I'm isolating for x, so this is going to be x equals minus 2y minus 6. Okay, so this is number 3. Actually, I'll just put the 3 here, because this is really the third. Sorry, this is really the third equation. Okay, so now what I want to do is I want to do my substitution. So I know that this came from number 2, so I have to take this side here and substitute it into the first equation where there's an x. Okay? So I'll just write that out. So, wrong color. So I'm going to sub x equals negative 2y minus 6 into number 1. When I do that, I get 2. I'll just change colors here for this one. That's the 2 here, and then the x. So my x, instead of writing x, I'm going to replace it with my expression that I have for x here. Minus 2y minus 6 plus 5y equals negative 18. Okay, so this is x, so this is like 2x plus 5y equals negative 18. All right, we're cooking. Now I'm just going to expand this out. So this is going to be negative 4y minus 12 plus 5y equals negative 18. I'm going to gather up my like terms. So minus 4y plus 5y is y. Minus 18, I'm going to move that minus 12 to the other side. And I get y equals minus 6. Then I'm going to sub y equals minus 6 into either equation, and if we go back and look, let's put it in the second equation. So that's going to be, now you could put it in here, that's okay. It's just the check that you have to use the original for. So we could put it into 3, sure, why not, because it's already isolated and we can just stick the y in and get x very easily. So x equals minus 2y minus 6 and x equals minus 2 times minus 6, so x equals 12 minus 6, and x equals 6. Now don't forget, we found the y first this time, so we have to make sure we've got the right possible ordered pair. So the possible solution is 6 minus 6, and we need to check. I'm going to have to write really small here. So we're going to check our originals. Remember, we don't go and check this one, because if we made a mistake rearranging, then if we check our answer in here, it will pick up that mistake, okay? And that's why we're checking. So 2x plus 5y, so the point is 6 minus 6. 2x plus 5y equals minus 18. This is going to be 2 times 6 plus 5 times negative 6 equals negative 18. That's 12 minus 30 equals negative 18. Negative 18 equals negative 18. So far, so good. And left side equals right side. Let's try the other one. This is going to be x plus 2y equals minus 6. And if I put in 6 here and negative 6 for y, I get 6 minus 12 equals negative 6. And indeed, this is true. I'm going to just do my conclusion up here since I don't have room. So therefore, the solution to the linear system is 6 minus 6. Okay. Let's do a trickier one. So this one's ugly in that there are brackets. So the very first thing you want to do is you want to simplify this so that it's really just got an x and a y and a number. So let's go. 2x minus 6 plus y equals 7. And I could rearrange it so that it's isolated already when I'm rearranging this. So let's go ahead and keep going here and say this is going to be y equals negative 2x plus 7 plus 6. So y equals negative 2x plus 13. Okay, I'm going to call that 3. And that one's already isolated for a variable, so that's awesome. The next one, 3x minus 2 times y plus 1 equals 0. I don't need to isolate it, but I am going to make sure that I've simplified it as much as I can. So let's just move that 2 to the other side. I think that's probably, either one of these last two versions would have been okay, but this has only got one number, so let's stick with that. So that's number 4. So now I'm going to use this system here to solve. I'm going to use equations 3 and 4. So now I have one isolated already. So I'm going to take the right-hand side of number 3, and in number 4, wherever there's a y, I'm going to replace it with minus 2x plus 13. Here we go. So sub y equals negative 2x plus 13 into 4. So we're going to say 3x. And again, if you want to rewrite the equation, that's fine. So it's 3x minus 2 times minus 2x plus 13 equals 2. So there's that part there. We replace the y with it. And now we're going to just expand it out and solve for x. So minus 2 times minus 2 is plus 4x. And minus 2 times 13 is minus 26. And that equals 2. So we get 7x equals 2 plus 26. 7x equals 28. And x, when you divide 28 by 7, equals 4. Okay, so far so good. Now, I can substitute back into 3 or 4 or 1 or 2. It doesn't matter here to find our y. So I'll go way up here this time. So I'm going to sub x equals 4. Let's see, which one looks the easiest to work with? Probably 3, because it's already isolated for y. So y equals minus 2x plus 13. Y equals minus 2 times 4 plus 13. Y equals minus 8 plus 13. Y equals 5. So a possible solution is 4, 5. We need to check. So let's just check 4, 5. So the first equation, this is where we absolutely have to use our originals, even if they're messy. So I'm rewriting out the first one. And this is going to be 2 times 4 minus 3 plus 5 equals 7. Now, don't forget BEDMAS. You don't need to distribute 2 to the 4 and the 3. You only do that when you have a variable in there. You can simplify inside these brackets, right? BEDMAS tells you to do brackets first. So 4 minus 3 is 1. So this is just 2 times 1 plus 5 equals 7. And so 7 equals 7 and left side equals right side. So far so good. And then for the next one, what is our equation? We've got 3x minus 2 times y plus 1 equals 0, I believe. And we substitute 4 and 5 in, so 3 times 4 minus 2 times 5 plus 1 should equal 0. Let's see what this all comes out to. So it's 12 minus 2 times 6 equals 0, and 12 minus 12 equals 0, and 0 equals 0, so left side equals right side. Okay, so far so good. Therefore, the solution to the linear system is 4, 5. Make sure it's in brackets. Okay. All right, last example. So it says, this is a little bit different. The following 3 lines intersect to form a triangle. Y equals 2x, 3x plus y equals 5, and x plus 2y equals negative 5. So it wants you to find the coordinates of each vertex. So if we were to graph this, why don't we just pull up Desmos and see what the graph of this looks like, of these 3 lines. So let's see if I can get this out of the way here. Okay, so we've got y equals 2x. We've got 3x plus y equals 5. And we've got x plus 2y equals negative 5. Oopsie. Equals negative 5. Okay, so I'm just going to close this off so we can see our triangle better. But there we are. We have the lines intersecting to form this triangle here. So we are being asked to find the point of intersection here. Oh, I can see the answer here and here. So what we're trying to do is find the intersection of this pair of lines, find the intersection of this pair of lines, find the intersection of this pair of lines. That means you're going to have to solve 3 linear systems. So we've got our work to do. Let's go. So for the first one, we're going to solve 1 and 2 here. So we could call, well, we'll just use y equals 2x and 3x plus y equals 5. Okay, so we've already got one of the variables isolated. We've got y isolated, so we don't need to bother isolating anything else. We can just take that and sub y equals 2x into 2. So we have to start with 3x plus y equals 5. That's our equation that we're subbing into. We're going to put, instead of y, we're putting 2x. So it's 3x plus 2x equals 5. So 5x equals 5 and x equals 1. And now we're going to sub x equals 1. Let's put it into 1. I think that's easier. So y equals 2x. Sub that in. We're going to put y equals 2 times 1. And y equals 2. So our possible point of intersection or solution here would be 1, 2. We still need to check our originals, so we'll do that here. See if I can squeeze this in. So check the point 1, 2. Y equals 2x. So y is 2. 2 times 1 is 2. And left side equals right side. So far, so good. And then the other point that we had was what? 3x plus y, I think, let me just double check. Yeah, equals 5. So when x is 1, this is 3 times 1 plus 2 equals 5. 3 plus 2 equals 5, and 5 equals 5. So left side equals right side. Don't forget to write that. Okay, 1 down, 2 to go. Let's do the next easiest pair, which would be the 2x with the x plus 2y equals negative 5. So that's going to be, let's go back. That's going to be 1 and 3. So we'll call that y equals 2x and x plus 2y equals negative 5. And so now we're going to sub y equals 2x into 3 again. So then we have x plus, this is 3. Now we're going to substitute, remember, this part here in where the y is. So this is going to be x plus 2, and instead of y, we're going to put 2x equals negative 5. So x plus 4x equals negative 5. So 5x equals negative 5, and when I divide through, I get x equals negative 1. And if we sub x equals negative 1 into our easy equation, into 1, we get y equals 2x, y equals 2 times negative 1, and y equals negative 2. So our possible point of intersection is negative 1, negative 2. Okay, let's check. We'll check the point negative 1, negative 2 with y equals 2x. And when I check that, negative 2 equals 2 times negative 1. Negative 2 equals negative 2. Left side equals right side. We're going to do the other one, which was, I can't remember. X plus 2y equals negative 5. I would have guessed wrong. X plus 2y equals negative 5. So x is negative 1 plus 2 times negative 2 equals negative 5. Negative 1 minus 4 equals negative 5. Is that true? Yep. Left side equals right side. So far, so good. I'm not going to make any conclusion yet until the very end. So, last one here. We got to use 3x plus y equals 5 and x plus 2y equals negative 5. So this is 2 and 3. Now this one's a problem because I don't have anything isolated, so I'm going to have to go ahead and make a fourth equation here by isolating one of the variables. You could either isolate the x in this equation or the y in this equation. So I think it's smarter to do the y up here. Well, actually, it really doesn't matter. So there's our new equation. Now I'm going to substitute y equals negative 3x plus 5 into the other equation. So this one came from here, right? This one came from this one. So now I have to substitute this into the other one. So into 3. Wherever there's a y, I'm going to replace it with minus 3x plus 5. So x plus 2 times y, which is represented by minus 3x plus 5, equals minus 5. So x minus 6x plus 10 equals negative 5. X minus 6x is minus 5x. And minus 5, the 10 becomes negative over here, so we end up with minus 5x equals minus 15, and x then, when I divide through, is minus 15 divided by negative 5, which is 3. Okay, now I'm going to sub that x equals 3 into one of the two equations. I think I'll substitute it into this one. So sub x equals 3 into 4. Alright, here it goes. We're going to have y equals negative 3x plus 5. Y equals negative 3 times 3 plus 5. And that looks like negative 4 to me. And y equals negative 9 plus 5. So y equals negative 4. So our possible point of intersection in this example is 3, negative 4. Okay, still got to check a third one. This is a lot of work, right? So we're going to check that we're going to check the point 3, negative 4. We're going to start with y. No, sorry, we didn't have a y. Let's go back to our originals. Don't forget, you always have to check in originals. 3x plus y equals 5. Let me erase that. And I'm going to replace the x with 3 and the y with minus 4. So notice here, I'll just take a second, I didn't put plus minus 4. I never have a plus and a minus beside each other like that, okay? A plus minus is a minus, so I just put minus 4. If you wanted to write plus minus, then you have to put the minus 4 in a bracket. It's just easier not to do that, but if you're not comfortable with just putting a minus, you can certainly do that. It's mathematically sound as long as you have the brackets. All right, this is 9 minus 4 equals 5, and yes, 9 minus 4 is 5, and left side equals right side. We're going to do one more check here. Let's figure out what our equation is. X plus 2y equals negative 5. Remember, you've got to do the original. And so this is going to be 3 plus 2 times negative 4 equals negative 5. Sorry about that. Let me fix that. Okay. So that's equal to negative, oops. What's going on? Going haywire here. Okay. So now I've got 3 minus 8 equals minus 5. Minus 5 equals minus 5. And left side equals right side. So I need to find room to do a conclusion somewhere. So I'm just going to do it down here. Therefore, the vertices of the triangle formed by the three lines are, and then just list them. So this one was 1, 2, comma, -1, -2, and 3, -4. Okay. Is this a right triangle? Show your work to support your answer. Well, that's a good question. This goes back to grade 9, but remember, everything you learned in grade 9 comes back, so we expect you to remember everything and to be able to answer questions based on what you learned in grade 9. So if we go back and look at Desmos, it kind of looks like a right triangle, but we have to support our answer algebraically. So what we're going to do here is we're going to find the slopes of 2 of those lines. Okay? And I think the 2 lines, if we go back again to Desmos, or if we had a sketch, this might have been helpful. This is the point 1, 2. This is the point -1, -2. It looks like the points formed by that line, the line formed by those 2 points, and the line formed by this point here from -1, -2, and the other point, which was 3, -4, are the points that I'm going to use to find the slopes. I don't care about the slope of this line. I'm looking for the slope of this line and the slope of this line. And what I want to do with those slopes, recall, is that if those slopes are negative reciprocals of each other, then this is a right triangle. Okay? All right, let's go. Let's find those slopes. Slope formula. So I'm going to find the slope of, let's just call it line 1, and that's going to be, remember, using these 2 points. So I'll just rewrite the formula for you if you've forgotten. So y1 minus y2 over x1 minus x2. Doesn't matter. You can have y2 minus y1. It really doesn't matter. It just means if you start with this y, then when you go to do the x, you got to have this x in the same starting position. All right, so m1 equals this one minus this one in the y's would be 2 minus 2 over 1 minus 1. And that's going to equal 2 plus 2, which is 4, over 1 plus 1, which is 2. So the slope is 2. Let's find the slope of the second line, and remember that was the slope of the line that was joining this point to this point. So -1 and -4. Again, I'll just rewrite the formula out. So y1, let's start with -2 minus -4 all over -1 minus 3. So that's -2 plus 4. That's a 3. So that's -4. So the slope of that line is 2 over -4, which reduces down to -1/2. Are these negative reciprocals? So I'll just write that question out. Is m1 the negative reciprocal of m2? I would say yes, because if I take this as a fraction and I flip it and I take the negative of it, I get this one. So m1, let's go back to black here, m1 is perpendicular, so that's my little sign for perpendicular, upside down t. So m1 is perpendicular to 2, so the triangle, actually I'm just going to change my mind on that. Let's just put a therefore statement. So M1 is perpendicular to M2, therefore the triangle is a right triangle, since the slopes are negative reciprocals. Okay. Done. That's the end of the lesson. Thanks for listening.